Today we are going to analyze in details how the phenomenon of reverse polarity increase the corrosion. It's the most important part, in my opinion, when you analyze the corrosion, is identify if you have leaks of current. And in the next episode we are going to check the procedure, physical procedure to test if you have leaks. But we are going to start in this episode analyzing where are the leaks. Yes, where is located the galvanic isolator? The galvanic isolator will be located in series in the ground line. In series here in the ground line. You cut it, the ground line, and you insert the galvanic isolator over there. Important situation. What is the capacity of my galvanic isolator in order to protect my boat properly? Now we are going to start with that analysis. Okay, the first element is install a good galvanic isolator in my boat. If your boat is only a DC boat, is a boat with only DC current, probably no, you don't need galvanic isolator. Alright? But if you have AC current, if you have AC panel, yes, it's mandatory install a galvanic isolator. But it's a small boat. But you have AC panel? You have shore power connection? Yes, I have. Okay, you need a galvanic isolator. You need to protect your boat, and the only way is with a good galvanic isolator. The people cannot imagine how aggressive is a reverse polarity connection in your boat. You can sink your boat. You can destroy the hardware in permanent contact with water if you have reverse polarity. And I am going to explain slow in this episode that situation, the situation of a reverse polarity, and how can I identify if I have reverse polarity. You remember the phenomenon of a reverse polarity, and it's basically when you have a switch, the neutral and the hot line. Remember, in the outlet you have 120, and suppose that this outlet is for 20 amps. Okay, you have 120 amps in this outlet, and this motor is for 15 amps, the motor that I have connected to the outlet. Okay, in the moment that I start the motor, the motor draw the majority of the current, and after that, when the motor is running, the consumption in amps is a little less. The rest of the current return through the neutral into the ground, because the ground and the neutral should be connected only at the source of the power. The source of the power, you have three different sources of power in your boat. One source of power is the pedestal, the transformer on the marina. At the source of the power on the transformer, neutral and ground are together. This is a bore, AC bore, that I prepared for use. In this particular example, the bore is single phase, but it's exactly the same for two phase or three phase. Alright, this is the typical AC panel in a boat. I have the main AC panel, the main breaker, the single breakers, and the main breaker is receiving the power from the transformer. The transformer is in the back, and the transformer receives the power from the switch selector. This is the AC switch selector. Generator position, inverter position, or shore power position. Shore power, inverter, generator, and this is the output. This is the switch selector for one position, two positions, three positions, and off. Right? This is the switch selector, AC switch selector. Some people, some technicians, some captains, they prefer, instead of a switch selector with three positions, they prefer three individual breakers with a slide bar. They say, oh, I am going to use right now my boat in shore power. I turn on this one on and the other ones off and off, inverter and generator. No, I want to work right now with the inverter. Okay, inverter on, off and off. No, I want to select right now generator. Okay, generator on,
off and off. Yeah. Some people prefer the breakers independent or the switch selector. This is too expensive in comparison with this. And now we are going to check the panel step by step. All right. This is the short power. The short power, hot, neutral, and ground. The ground goes directly to the ground bus bar, and the ground goes directly. This is the isolator transformer. Pass through the isolator transformer. Continue is interrupted, and you install the galvanic isolator. The ground continue into the bonding system, and from the bonding system finish into the sink. All right. In each breaker, you have in front of the breaker, if you check in the other side of the panel, let me show to yours like this. In front of each breaker, you have one LED. When you activate the breaker, the LED should be on. The LED, for this particular case, for this particular example, is similar to this one. It's an LED. One leg for neutral and the other leg for hot. Okay. All the LEDs, they have the neutrals, the yellow ones, connected to the neutral bus bar. And the hot is connected in the output of the breaker. When the breaker is activated, immediately the LED is on. Because the light, one leg is on the neutral bus bar and the other leg is connected here in the output of the breaker. This is the breaker for the light. Now we are going to turn it, the board, and we are going to check the connection. The LEDs should be connected in the output of the breakers, not in the hot line at the input. Because if you connect here, the LEDs are on all the time. The voltmeter, one hot line is connected here with the hot line bus bar. And the neutral is connected to the neutral bus bar. And the frequency is connected neutral with neutral and hot with hot. That's too simple. Connect voltmeter, frequency, and ammeter. In this moment is connected the short power. I am going to select short power, inverter off, generator off. I have short power. I have power on the short power light. The LED is on, and right now I am going to connect the lights. Okay, the lights are on. Or the battery charger. The battery charger start. The lights start, and the outlets. Those are the outlets. This is my boat. The light is on because it's receiving power. What is the meaning of that? The green light is on is because my polarity is properly. My polarity is properly. What happens if the reverse polarity will be on? If the red light for reverse polarity is solid, is on, it's because I switch the hot and the neutral on the panel. I connect on the neutral bus bar the hot, and the neutral is on the breakers. What happens in that case? If I have reverse polarity here, probably the light is on. This equipment is working, the outlets are working, but the neutral, let me explain that one. This is a critical situation. I'm going to turn off everything. Let me explain what happens if I have reverse polarity. If you have reverse polarity, it's because you connect this one, the neutral, on the hot bus bar, and you connect the hot on the neutral bus bar. You make a mistake and you connect the neutral on the hot and the hot on the neutral.